Hello everyone, welcome back to another physics YouTube video here on the Furbank Physics YouTube channel. Today we are going to be doing 2D collisions. Now what is a 2D collision, I hear you ask? Well, a 2D collision is a collision of two objects in two dimensions, obviously. Now, in this example, we have a car speeding towards an old woman at a considerable speed. Now, unfortunately, the old woman does get nudged while crossing the road at a speed of 300 meters per second. Now, that is quite fast, but to make this a bit more exciting, it is at 50 degrees as well. Now, for the sake of easiness, both objects, the car and the woman, are 1,200 kilograms. That might seem a bit ridiculous, but we'll just go with it for now. Now, the question is to calculate the initial velocity of the car at point V here. So the initial velocity of this car before the collision. Now, today, how we're going to do that is by using the formula for momentum, which for 300 times by 1200, P equals mv, of course. Let's write that down. That's you, who cares? So it's 300 times by 1200, which is, of course, obviously 360,000 kilograms per second, which I definitely did in my head. Now, what we need to do is work out the vertical momentum of this here, so that we can get to find the momentum of the car up here. How we're going to do that is timesing by sine 50. We're going to do that by doing 360,000 times by sine 50, which is easy to work out. It's only 275,775.9995 kilograms per second, which is this line here. Now, what a lot of people don't realise about this is that this point here has zero vertical momentum. The car has zero vertical momentum before the crash because it's going at a horizontal speed. So if this is 275,000, then this must be exactly the same in order for it to cancel out and equal zero. So this is exactly the same number. So now we have 275,775, whatever it was there. And that's all the information we have at the moment, until in a few seconds, because if the two objects are exactly the same mass, the angle between them is exactly 90 degrees, which means that is 40 degrees. It's worth mentioning, if these are not the same mass, then they, of course, well, not of course, but they will be different. They won't equal 90 degrees. Most likely. So now what we can do is do 275,775.9995 divided by sine 40, which is this angle here, of course, which equals, what is it, 429,031.2933. That is this line here. This is the momentum of the car after the collision. Now, because momentum is conserved and the angle between the two momentums calculated up here is 90 degrees, V, the line here, is effectively the hypotenuse of this triangle here, which means you can use, well, Pythagoras, so you can do 360,000 squared plus 429,000, that's 1.2933 squared, and square root all of that gives you V. And the answer to that is obviously 560,060.5776 kilograms meters per second. And now we can calculate what V actually is, which is a speed, by dividing by the weight, which we know is 1,200 kilograms up here. So we do 560,060.5776 divided by 1,200, which gives us 466.717148 meters per second, which is V. Now, that is incredibly fast. It's about 1.5 Mach, so about 1.5 times speed of sound. Realistically, is anyone going to be doing that? Perhaps if they've got a jet engine on their car and they really don't like old women, this scenario is plausible, I promise you. But anyway, thank you for watching, everyone. Don't forget to drop a like and subscribe with all 15 of your different accounts, please. Hopefully we can get this monetized at some point, even though it's only 5 minutes long. But it'd be greatly appreciated, so that I could get an extra 1 penny in my paycheck. So thank you very much, and goodbye.